Okay, so we are still differentiating. We are going to talk today about something called implicit differentiation, and I will tell you why it's called implicit here in just a second. So it starts off, says, suppose you were asked to find the slope of the tangent line. So slope of a tangent line, what does that mean we have to find? Derivative, right? Yeah, like an f prime type of situation, right? Of the curve x squared plus y squared equals 25 at this point. So using what we know right now, you need to solve for y and take the derivative. So that's what we're going to do. So we're going to have x squared plus y squared equals 25. So I want to solve for y, so that means that y squared is equal to 25 minus x squared. So y is equal to plus or minus the square root of 25 minus x squared. Okay, everybody agree with that? All that so far? Okay, does this become 5 minus x? No, it does not. No, you do not get to distribute that. But we want to find the derivative, so in order to find the derivative, we would like to put this as a 1/2 power. So we'll do y equals plus or minus, then that's going to be 25 minus x squared to the 1/2 power. Okay. All right, so now we'll find the derivative. So remember, when we do the derivative, this is what we're doing here. We're going to take the derivative with respect to x of the entire thing, okay? And we're doing whatever we do to one side, we do to the other. So on this side, when we take the derivative, that's why this becomes dy dx. Okay, that's what this is right here. Because that's how you take that derivative. And then that equals, it's what we've been writing. I just want to make sure you understand why it is what it is. We can keep the plus or minus, and then bring the 1/2 down, plus or minus 1/2 times 25 minus x squared to the negative 1/2 power. Chain rule says I then do the derivative of the inside, which would be negative 2x. Everybody with me so far? So I have this negative exponent, so dy dx is equal to plus or minus, I'm going to make this into a fraction, right? Then I'm going to decide what goes in the numerator, what goes in the denominator. So with this 1/2, a 2 goes down here. With this right here, that's going to be the square root of 25 minus x squared. And then I have a negative 2x here in the numerator. Everybody with me so far? Can I reduce this a little bit? Yes, I can get rid of the 2's. And since this is plus or minus, really plus or minus the negative just means one of them is going to use the negative, one of them is not. Since I have this out here, I don't really even need that. So I really just have dy dx equals plus or minus, I'm going to have x over the square root of 25 minus x squared. Now it said I want to find this at the point 4, 3. So I'm going to have dy dx evaluated at the ordered pair 4, 3. Okay. Put the whole, it's like saying at x equals 4. I just put the whole point there. That's another way to do it. I'm only using the 4 because I only have an x in there. Does that make sense? So this becomes plus or minus, I have 4 in the numerator, square root of 25 minus 4 squared in the denominator. So that gives me plus or minus 4 over, so 25 minus 16 is 9, take the square root and we get 3. So let's think about this. We have 2 answers. Does it make sense to have 2 answers? No, especially since it says the slope of the tangent line. There's only one tangent line at every point. Does that make sense to you? There's just one. So, but we get 2 when we evaluated at 4. Do you know what this is the equation of what this would graph? It's the equation of a circle, okay? It's why, sine squared plus cosine squared equals 1. It's the whole all of that kind of all goes together. So if I have a circle, let's just graph our circle, and it would mean that my radius is 5, but so there's a semi-decent circle there. So that means that I have a point at 4, 3. Let's see, 4, 3. We'll say it's right about there. We'll say that that's at 4, 3. Right, and there's my tangent line. And then at 4, I have another point. What would that ordered pair be? 4, -3, right? And then here's that tangent line. So if I'm looking for the slope at the point 4, 3, do I want the positive or negative version of that 4/3? Is this slope positive or negative? Negative. So the slope would actually be the negative 4/3 is what we would be looking for. Couldn't that just come from the negative? Say that one more time. No, not necessarily. Because the reason you get two answers is because you're just substituting in the 4. Regardless of whether this would have been positive or negative, the same thing would have happened. Okay? All right, so this process, which is the process that we've been doing, is called explicit differentiation. That means we had a function. First of all, it was a function. Is this a function? No, I'm sorry, not that. Is this a function? Sorry, you're right. This is a number. I was pointing to the wrong thing. This is not a function, right? So yes, I solved it for x, but the reason it didn't work out nicely like the rest of it did is because y is not a function of x in this situation. So we can't, when we explicitly solved for y, that's what an explicit equation looks like. That just didn't work out because it's still not a function of x. So that's why this is called explicit differentiation. And then it says, suppose you were asked to find the slope of the line tangent to this curve. It would be very difficult or even impossible, and a lot of times, to actually solve it for y and do what we've been doing. So we need another process. So another technique is needed, and that's what's called implicit differentiation, which we'll do today. Okay? And we'll take the derivative without solving a derivative, without solving for y. Here's examples of explicitly defined functions. They are solved for y. These are implicitly defined relationships. They have x and y, and they're not solved for y. Even if maybe I could solve for y like we did on that one, but we don't want to go down that road because it messes a lot of other things up. Okay? So let's look at this right here and see what we're going to do. So it says we're going to differentiate with respect to t. We've been differentiating everything with respect to x, dy dx, with the derivative of y with respect to x. So now we are going to differentiate with respect to t. And then it says, since we must apply the chain rule, I'll explain how that works in just a second. It's not nearly as, you don't even notice really that you're doing the chain rule. Each derivative will have a d blank over dt as part of the derivative. So as we go through here, term by term, I'm going to take the derivative of y cubed, which that's still is easy, 3y squared, right? Then it said you apply the chain rule. So this is something to the third power. So I had something to the third power, so it's 3 times that something squared. And then the chain rule says you take the derivative of what's in the inside. The derivative of y is dy, in this case, dt, because it says I'm taking the derivative with respect to t. Then y squared is going to be plus 2y dy dt. Then when I take this derivative, it's going to be negative 2x dx dt, right? Because these were y's, that's why I use dy dt. This is an x, that's why I use dx dt. And then the derivative of negative 4 is 0. So it doesn't even matter what you put next to it because it would 0 out anyway. When we did dy dx, y was changing based on x, right? Because it's a dependent, it's a function. Here, y and x are both changing with respect to whatever t is. Let's say that it's time, okay? As time goes by, y is changing at a specific rate, and x is changing at a specific rate, because these are rates which represent our slopes, right? Here's that function graphed. So I want you to think about as time goes by, let's say that we start, at time is 0, and we're going like this, okay? Right here, between 0 and 1 second, or 1 minute, or 1 day, whatever you want to do, x is changing very quickly, but y barely changes at all, right? X and y are changing at different rates. That's why we have to have the dy dt and dx dt. They're different, okay? Make sense? When you do implicit differentiation, which means it's not solved for y, you don't start off with dy dx equals blah, blah, blah. You have to put it in there as we go along. So here's the exact same function, but this time it says differentiate with respect to w. Okay? Question or no? It's weird at first. It's a new letter, I know. But here's why we're doing that new letter. Because t was kind of a new letter to throw in there too, right? So when I do this, I do 3y squared. Since I'm differentiating with respect to w, this is dy dw plus 2y dy dw minus 2x dx dw equals 0. So the only difference between these two are what's in the denominator here, because you're being told what to differentiate with respect to. Okay? You good so far? So we just did these two random things to get you used to putting them in there like that. All right? And this will make a little bit more sense as we go along. Everybody good so far? With me? And when you check things, like if you want to make sure that you didn't leave any of these out anywhere, you have 2 y terms in here, you should have 2 dy dw's. You have 1 x term, you should have 1 dx dw. Okay, so you don't leave one off somewhere. All right, flip it over. We have the exact same equation. This time it says differentiate with respect to x. So everything will have d something dx on it. So we do 3y squared. This would be dy dx plus 2y squared, no, just 2y, sorry, dy dx minus 2x dx dx, right? Because we're deriving with respect to x equals 0. So it's the same thing we just did with t and with w. Does everybody understand where everything came from and why? Okay, so now let me ask you this. What is the value of dx over dx? 1. This is 1. So if you are taking the derivative with respect to something and that something is in your equation, we don't really have to put this, because in the end this is just 2x times 1. Does that make sense to you? You good on that? All right, so we could rewrite this. Let's go ahead and rewrite this as 3y squared dy dx plus 2y dy dx minus 2x equals 0. Everybody with me? What I have in green is the same that I have in blue. Since this is 1, we basically just don't write it. Okay? So once you go through and you take the derivative of each little piece and you label them as necessary, then we actually want an answer. What is dy dx? So we're going to use algebra here to rearrange and solve for dy dx. So just like anything else you solve, I want all the terms that have a dy dx on one side and the terms that don't on the other side. So I'm going to move this 2x over here legally and algebraically so that I get 3y squared dy dx plus 2y dy dx equals 2x. Okay, just simple algebra. Now, what do I need to do with my dy dx to be able to do something with it? Why is this missing? I'm going to lose my mind. You better not touch it. Okay, so I could factor out a y, but what I want to get by itself, I don't want to solve for y. What am I solving for? Dy dx. So this is what I actually want to get together. So instead, I'm not really looking for a GCF here. I want to factor out the dy dx. Does that make sense? So I'm going to factor out the dy dx That leaves me with 3y squared plus 2y equals 2x. And then divide, yes. So my dy dx is equal to 2x over 3y squared plus 2y. And that's your dy dx. And we have an x and a y in it. That's one reason why over here, when I did this, I put the point there, because that's what we would have to do. If we did this with implicit differentiation, this one right here, this would give me 2x plus 2y dy dx equals 25. Y'all agree with that? So then if I want to solve for dy dx, I'd have 2y dy dx. dy dx equals 25 minus 2x. So then dy dx is equal to 25 minus 2x over 2y. Right? Right with me? So then if I evaluate that, if I do dy dx evaluated at that point, which is 4, 3, that's going to give me 25 minus 2 times 4 over 2 times 3. Okay? So what's 25 minus 8? 17. Wait, is this not working out? What did I do wrong? Oh, I'm an idiot. Dang it. I've done this. So what did I do wrong in my derivative and y'all didn't stop me? 25 should have been 0. You know what's funny? When Ms. Bruce was here yesterday, we were talking through this lesson. She was like, these are the common mistakes, and this is one of the common mistakes. And she goes, but I do this all the time too. I don't know. I go, me too. I had to erase it so many times in my work. Like I'd catch it in the next step, but I didn't catch it when I was saying this to y'all. So, do you understand why that's supposed to be 0? Okay, so I'm gonna. I could fix this a little bit at a time, but let me just start over. I just knew it wasn't right because it wasn't coming out. Okay, 0. There. Oof. All right, 0. So that means that I was so confident too. 2 times dy dx. I'll let that one slide on y'all because I know this is new to you. And then when I divide, I get dy dx equals negative 2x over 2y. So that's just negative x over y. So when I do dy dx evaluated at 4, 3, that's going to give me negative 4 over 3, which is what I got after we've had to think through it over here. Okay? And that is a whole lot easier than doing this and doing this anyway when this didn't even give us what we really wanted. Okay? This will not seem like such a big deal once you practice it some, I promise. It'll start to make more and more sense just like everything else. Okay? We good? All right, so let's do another one. Let's flip back over. So we're going to take this equation and we're going to find dy dx. And it says, don't forget the product rule and be careful not to make a grouping error. So pay attention to these things that I say. When I want to take the derivative of this first term, what rule am I going to have to use? Product rule. So my product rule says I take the derivative of the first, which is just 1, times the second, which is y squared, plus the first, which is x, times the derivative of the second, which is 2y dy dx. Right? I didn't have to put anything here because I took the derivative of x, and that becomes dx dx, and we don't need to, right? So that took care of this piece. Everybody with me? Am I going to have to use the product rule on this also? Yes. How many terms do I end up with my product rule? 2, right? So I need to, when I do minus, I need to open parentheses. That's where your grouping error might happen. I take the derivative of the first, which is 3x squared, times the second, which is y, plus the first, which is x cubed, times the derivative of the second, which is 1 times dy dx, equals what? 0. Yes, I don't want to mess that up again. Everybody with me so far? Ask me questions. Let me say this again. Did this. I took the derivative of the first, that's 1 times the second, y squared, plus the first times the derivative of the second, so I have to put that dy dx on it, minus, and then I open my parentheses, the derivative of the first times the second, plus the first times the derivative of the second, which is just 1, but I have to put the dy dx on there. Okay? Then I can count my terms. I have 2 terms that have a y in it in the original, so I should have 2 dy dx terms, and that's what I have. Okay? Everybody with me? All right, so that means I'm going to clean this up a little bit. Y squared plus 2xy dy dx minus 3x squared y minus x cubed dy dx equals 0. Because I had to distribute my negative. Everybody with me? Now we got to get our dy dx by itself, so we can leave all the terms of the dy dx on the left, move everything else to the right. So I get 2xy dy dx minus x cubed dy dx equals, so when I move this over, that'll be a minus y squared. Move this over, it'll be plus 3x squared y. Everybody with me? Then what do? Factor out the dy dx. So dy dx times 2xy minus x cubed equals negative y squared plus 3x squared y. Then what do? Divide. Yeah, dy dx is equal to negative y squared plus 3x squared y over 2xy minus x cubed. Okay. Notice again, with implicit differentiation, you can end up with x and y in your answer, where with implicit, when we had solved it for y, you only had x's in your answer. Okay. What questions do you have? Okay, so this is down here because we're going to do this one more way. We're going to take this step right here and we're going to rewrite it right here. So y squared plus 2xy dy dx minus 3x squared y minus x cubed dy dx equals 0. Okay. So what we did, that's all kinds of crooked because I was writing funny. What we did is we left our dy dx terms on the left and moved everything else over to the right. Could we also move the dy dx terms to the right and leave everything else over on the left? Okay, yes, so let's go through that here. We've got y squared minus 3x squared y equals, then that would be negative 2xy dy dx plus x cubed dy dx. Okay. So the process is still the same. I'm going to have to factor out that dy dx, so I rewrite this. Y squared minus 3x squared y equals dy dx times negative 2xy plus x cubed. So then I can divide and get that dy dx is equal to y squared minus 3x squared y over negative 2xy plus x cubed. Everybody okay with that? So there's a reason that we did that, not just to show you could do one side or the other. Look at the two answers we got. Are they exactly the same? The signs change. They don't look exactly the same, but they are exactly the same. Because let me ask you, if I multiplied this by -1 over -1, that'd be a value of 1, right? And when I multiply this by -1, the signs change, right? Multiply this by -1, the signs change. So the reason you want to see this is that if you come up with this and it's a multiple choice answer and this isn't here, it doesn't mean that you're wrong. If your answer isn't there, try changing the sign on every single term and see if that works. It's only for irrational, but does that make sense? So these two actually have the same value. Okay, everybody good? What questions you got? All right, here's the next sheet. Let's see how far I can get on this today. All right. So we have this function, or it's not a function, I'm sorry. We have that equation, and we want to evaluate this at the point 2, 6. All right, so let's differentiate this first. We have to use the chain, or not the, I'm sorry, not the chain rule, the product rule right here. So I have the derivative of the first, which is 1, times the derivative of the second, which is dy dx, plus the first, oh, I did that wrong. I don't even know what came out of my mouth. Jeez Louise. Okay. The derivative of the first times the second. The second is y. I think I said times the second, and then I put the derivative. The derivative of the first times the second, plus the first times the derivative of the second. You okay with that first term there? Do I have to use the product rule on this term? No. The derivative of 3y is 3 dy dx. Do I have to use the product rule here? No. And so that's negative 10x, and then that equals 0. Then you can check yourself. See, I would have caught myself, hopefully, if I'd have gone back and I've got 2 y terms, I should have 2 dy dx terms, which I do. So here's the nice thing. If you're going to evaluate it at a point, you can save yourself some work and some headache if you substitute it in right here. Okay? So I have y. Y is what? 6 plus x, which is 2 dy dx. Don't have anything to substitute in for that, right? Plus 3 dy dx minus 10 times 2 equals 0. All right, so 2 dy dx plus 3 dy dx is what? 5 dy dx. And then I have a negative 20 and a positive 6, so that's minus 14 equals 0. So that means that 5 dy dx is equal to 14, and dy dx evaluated at 2, 6 equals 14 over 5. Okay. I could have used algebra and solved for dy dx and then substituted it in. That's fine. But this cuts down on your algebra and your factoring and your writing and everything. Okay. We all good so far? All right. So then B says to write the equation of the tangent line to the curve at the point 2, 6. So to write the equation of the tangent line, I have to have a point, and I have to have the slope. What's the point? 2, 6. What's the slope? 14/5. Because the derivative is the slope, right? Slope is still the derivative. I had to have both points, x and y, in order to find that. So I have everything. I just need to say that y minus 6 is equal to 14/5 times x minus 2. Okay. What questions you got? Okay. Let's see if we can make it through one of these trig ones. All right. So, am I going to have to use what kind of rule do I use on the left? Product. Derivative of the first. So the cosine of x, that derivative is negative sine x, right? Derivative of the first times the second, plus the first, which is cosine of x, times the derivative of the second. So the derivative of sine is what? Cosine of y, and then dy dx, because that's really the chain rule right there. Cosine of y, and then you take the derivative of the inside. And what does that equal? 0. Everybody with me so far? So I'm going to take this term, I'm going to move it over to the right, so I've got cosine x, cosine y, dy dx equals sine x, sine y. Do I have to do any factoring? No, this is all one term. I just need to divide by that part. So dy dx is equal to sine x, sine y over cosine x, cosine y. So that is a safe stop answer. It could also possibly be a multiple choice answer, but you could simplify this. What's sine over cosine? Tangent. So this could be tangent x, tangent y. It's the same thing either way. Okay. What questions you got? We good? We're going to save this next one for tomorrow. I'm going to give you your assignment, okay? And you're going to need to do this on a separate sheet of paper. Do not even try and cram this on here. The answers are on the back, but I will have it all worked out for you also, okay? We good? Practice. Practice before tomorrow, before I give you, before Monday. Well, practice before tomorrow too. Whatever.